aware that I may make this. And eventually what I want to do is probably make this a lot. I want to probably tell people about it, make it public so that people can watch it live, because I think that'll increase traffic to my website. Maybe, I don't know.
Okay.
I doubt anyone's going to want to watch it, but who knows? Okay. So your questions: graph the solution of the given system of linear inequalities. So the first thing I'm going to do is color code it. So let's make this red. And notice this red equation is in slope-intercept form. And the easiest way to graph an equation when it's in slope-intercept form is to first graph the intercept. Your intercept is -2, your y-intercept, I should say, so it's right there. So -2 is right there. And then use the slope, which is 5, to find the next point. And that means 5/1. So m equals 5/1. And 5 is your rise, and 4 is your run. So when I rise 5 from here, I'm starting at -2, I'm on that dot. I go 1, 2, 3, 4, 5, I'm at +3, and I run 1, and I'm at 1. So 1, 3, 1, 3 is going to be my next point. So now if I draw the line very carefully, which I don't know if I can do that very carefully with this. Let me see if I can do it on your Jamboard. Can I do it carefully if I go to
I can draw it.
my computer? Let me see if I can. I'm actually on the Jamboard on the computer too. And I'm trying to see if they have a line tool. Do they have a straight line tool?
I'm not sure.
On this? I don't know. I don't think they do.
I drew the rest of the points. I don't know why they're not showing up. Must be.
Yeah, see, you can't really draw it. I can draw a diagonal, a box where the diagonal would be it, but I can't draw that. So let's delete it. So yeah, so I do see them on, here, let me go to edit axis again. Sometimes this happens when I've got it open in 2 places. Let me open it again. There we go. Close enough. We want to try to, we would prefer to be able to draw that line exactly perfectly. Actually, you know what? Here, undo yours. Click undo a couple times. And I'm going to show you a little trick that I learned. Another trick I learned as I was doing my research and the way to do this. So now let's draw the other line in blue. And notice this also. Notice I'm writing the equations. This also, it's x plus 2. That is slope-intercept form. So 2 is my y-intercept. And the slope is up 1/1. Hey, there's the intersection point. I guess that's fine. We don't have to make it any more perfect than that. Let's just kind of draw as good as we can. Like that. And for the red one, we're going to draw it like this. That's pretty darn good. Now, I shouldn't have drawn it quite that perfectly yet, because notice one of them is a dotted line and one of them is a solid line. Can you tell which is which?
The dotted line is the red line.
That's right. The red line is dotted because it doesn't have an equal sign, which means all of those points that are on the actual line are not actual solutions to that equation. For example, if I take the point 1, 3 and I plug that into this inequality, if I plug 3 in for y and 1 in for x, notice what I get. I get 3 is less than 3. And is that true? Is 3 less than 3?
No.
That is not true. So therefore, there should not be a dot on that point. There should not be a solid dot. In fact, I'm going to go through and make all these dots. I'm going to make these dots open dots now, because that's what they really should be. That should be an open dot. This should be an open dot. And the other one should be open dots. Okay. Now, which way am I going to shade the red line? Well, when it's written in this form, when it's written in slope-intercept form like this, the shading is basically whatever. If the y is on the left, if it says less than, that means you go below. The y is below it. So which side is below the red line? Is it the side to the right or the side to the left? Which is below the red?
To the right.
That's right. To the right is below it. So I'm going to shade this like that. And for the blue line, notice it's also less than, and which means it is also below the line. Because of the equals to it, I made it a solid line because all the points on the line happen to be solutions as well. So which way is it shaded for the blue? To the right or to the left?
Also to the right.
That's right. So to the right of the blue as well. So here's the blue. I do it in a different color and a little bit angled. And now the solution for this system, it says graph the solutions of the given system of linear inequalities. The solutions are, I'm going to go ahead and erase all of this right here. And I'm going to erase this blue, the stuff that is not double blue and red. And now I can see the solution is everything from that 1 point right here, the point 3 comma 1, or sorry, 1 comma 3, that point, following the blue line up, including the blue line, is part of the solution. And then following the dotted line, but not including the dotted red line below it, and everything to the right of that and below it is the solution. And what that means is this, is the point 8 comma negative 3 a solution to the system? 8 comma negative 3? It sure is. Which means when I plug in 8 and negative 3 for x and y respectively into those two inequalities, it will be true. I will have true, both of them would be true statements. Like 7 is less than 18 or something like that. And how about points over here? Are they solutions to the inequality?
No.
No, they aren't. In fact, these are not solutions to either inequality. These ones over here. These ones over here are solutions to the red, but not the blue. And these ones over here are solutions to the blue, but not the red. And so therefore they're not solutions to the system. Make sense? All right, let's do the next one. Graph the solution set of the system. So we want to, now in this case, the equations are written in slightly different form. This is called, what do they call it? Standard form? What does your book call it? Or is it general form? Whoops, I kind of forget.
I think it's standard form.
Okay.
Not
So
really.
here's the, I think that's true. I think it's standard form. I can't remember which one general form is, but it actually, for linear equations, it might be both. This might be standard and general. So this equation is not in slope-intercept form. I wouldn't waste my time putting it in slope-intercept form either. And I'll tell you why. Because this format, to me, is really nice to find the intercepts. And I call it the cover-up method. When I plug in 0 for x, that makes this gone. It covers it up. And now, while I'm doing this, tell me what y would equal. Sorry, let me make this an equal to sign, not a less than or equal to sign. What would y equal if I cover up the x term? What's y equal? Can you do that in your head? What is it? 0 comma.
Man. -8.
Very good. 0 comma -8. And now if I plug in 0 for the y variable, in other words, if I cover this up, solve that in your head. Divide both sides by -2.
-4.
Perfect. -4. So there are my two intercepts. My intercepts are 0, -8, and -4, 0. And how many points do you need in order to get the equation of a line, or in order to graph a line?
Just 2.
You just need 2. So those are the two best ones. The two intercepts are the two best points, in my opinion, if you can see them. If there are 2, they're not always 2. Like, for instance, this next equation, since there's no x, what is that equation? Y equals -8 is what kind of line if there's no x on it?
It's just a straight line.
All lines are straight. What do you mean by that? Do you mean horizontal or vertical?
Oh yeah, that would be a horizontal line.
That's right. Y is always equal to 8. It doesn't matter what x is. Y is always equal to 8. Now, is that a solid line or a dotted line? I should have asked that about the blue one as well. Are the blue and red lines solid or dotted?
They all are going to be solid lines.
They are both solid lines. And even this last one, which we shall do in the color of black, even this last one is a solid line, right? And what is the line x equals -4? What kind of line is that?
That's also a solid line.
It's solid. And is it vertical, horizontal, or slanted?
Vertical.
It is vertical, going through -4. X is always equal to -4, no matter what y equals. X equals -4. All right, now let's shade them. So the blue line, and you could have shaded them right after you drew them, but I like to wait. The blue line, if I plug it now for this, I can't just look at which way the shape is because it's not in slope intercept form. Y is not by itself, neither is X. And don't bother putting it in that form. All you need to do is find a test point. And if 0, 0 isn't on the line, it's the easiest point to use. And see if that's a solution. Plug in 0, 0 and ask yourself, does that work? If I plug in 0 for these, is 0 greater than or equal to 8? Is that a true statement?
No.
It is not. So am I shading in the direction of that point?
Mm-mm.
I'm shading in the opposite direction. Got it?
Mm-hmm.
So this blue line gets shaded this way. Now, how about the red line? What does y is greater than or equal to -8 mean?
If you take a y value, this to be equal to 8.
So is greater than or equal to. So is it above that line or below that line?
That's going to be below.
Greater than 8 is below? I'm sorry, greater than -8? What does it mean to be greater than? Which values are greater than -8? All these values
above.
or all these values? Yep. Do you hear how I'm thinking through it?
Yeah.
So it's above. And how about the black line? How about the last one? Is it to the right of the black line or to the left of the black line? Greater than is which way?
To the right.
To the right. Now, I'm going to go ahead and erase all of the things that are not intersecting all three places. And what am I going to be erasing?
The ones that aren't solutions to all three of them.
Mm-hmm. And whoops. Let's try that again. So I'm erasing this. Right? And I'm erasing, and you technically could even erase these lines now if you wanted to.
Yeah.
Just so that people aren't confused. And then I'm erasing this. This is so satisfying, isn't it?
Yeah.
And I'm erasing this below.
Mm-hmm.
So there's my solution right there. That's my solution. And they're going to ask you for these points, just so you know, and you can kind of find those points by solving the system. Or you can just tell, if you drew it carefully, you can see what those points are, right? So this point here is -4, -8. This point here is 0, -8. And this point is -4, 0. And those are important points because you're going to do something soon where you're going to take those points, those endpoints, and you're going to use them to find out which one of those is the best point for a given.
Yeah, we already did that. I actually have all those on here.
Perfect. All right. Well,
like
I guess
maximization or whatever.
You got it. To max it, you're trying to maximize the function. That's right. Okay. So graph the solution set of the system of linear inequalities. So what form are these written in?
Here, wait, I can draw it in.
All right, you do it. Let me see you do it.
Okay.
It's time for you to shine.
-4. It's a -4 slope, so you go down 4. 1, 2, 3, 4. Oh, that was so bad. Okay. Gotta plot some more points here. And then 2. These are kind of easier.
Good, good, good.
And then this part always trips me up, the like shading. So
Well, when they're in slope intercept form, all you have to do is look at it, right? So for the blue one, what would less than, why is less than mean? Look at the line and ask yourself, is less than this way or is less than this way?
less than would be this way.
That's right. You see how I'm thinking through it? It's not just left or right. It depends on what the slope is. It depends on which way it's slanted. So how about for the red one? What would greater than mean?
I mean this way. Right?
Ask yourself the question. Is that greater than the red line? Is everything in that direction greater than that red line? Or is it less than? Is that all less than the red line?
Greater than? Wait.
No, everything here is below it, right? Can you see, since it's slanted
yeah.
this way, everything here is below it, you know,
Oh.
like the Y value. Look at here, look at like this, Sarah. This Y value, anything over here is below that Y value. Got it? All these things are above that Y value. That's how we're thinking of it.
Okay.
And then you can erase all the rest of it if you want. Like I said, erase everything that's not a solution.
All right.
Good?
Mm-hmm.
All right, do we have more? Let's go.
I've got this one.
This is the objective function, right?
Yeah.
Okay. So it says, baking a tray of banana muffins takes 4 cups of milk, 3 cups of flour. Baking a tray of blueberry muffin takes 2 cups of milk and 3 cups of flour. So let's make a little table over here. So we've got banana. Let's see, we have cups of milk and we have cups of flour and we have banana muffins and we have blueberry. Oh, it had to be like that, doesn't it? Banana and we have blueberry. And so 4 cups of milk and 3 cups of flour, and blueberries take 2 cups of milk and 3 cups of, ooh, okay. The baker has 16 cups total of milk. So he has 16 cups of milk available, and he has 15 cups of flour available. He makes $3 profit. So this is profit. $3 profit per tray of banana muffins. Was this all about trays? A tray, yeah, okay. So this is all in terms of trays, so I don't have to worry about the units. He makes a $3 profit on banana and $2 profit on blueberry. How many trays of each type should the baker make to maximize profit? So let's first write our profit equation at the bottom, because that's the bottom line. The profit is, we're going to call this, let's call this X, and let's call this Y. Okay, we'll call that X and Y. Okay, so for every tray of banana muffins, he makes $3. So 3 times X plus, for every tray of blueberry muffins, he makes $2. Okay,
Yeah.
There's our profit equation. So we want to find out what points, what values we can put in there, and that's called the feasible region. There you go. There's your objective function. Good job. So the feasible region is going to be the feasible region is going to be based upon these equations. So let's make our milk equation. Okay, so our milk equation is this. So I'm taking these things right here. I've got 16 total, and that has to be greater than or equal to the total number of cups I make for the muffins. I'm sorry, for the banana muffins, plus the total number I use for the blueberry muffins. Does that make sense how I came up with that equation?
Yeah.
So Is the Jamboard stopping on you?
Yeah.
Okay. Sometimes you have to close it and open it back up. It gets a little finicky sometimes. So 4 times x plus 2 times y has to be less than or equal to 16. And then the other equation I'm going to write, and I'll make this one blue, is the flour equation. And the constraint of the flour is that I have 15 cups of flour available, and it takes 3x and 3y. I can actually simplify that whole equation if I wanted to. I can divide everything by 3, and it would just be x plus y is less than or equal to 5. Does that confuse you, or does that help you see that that's a good way to do it?
No, that makes sense.
In fact, I can simplify the other equation and do what with it?
You could divide everything by 2.
That's right. And I would get 2x plus y is less than or equal to 8.
Yeah.
And that just makes it easier because my numbers now, it's a little bit easier for me to see what my solutions are. So let's do the old, for the red one, for the milk equation, let's do the old cover-up method. What's the x-intercept? When I plug 0 in for x, what do I get for y? What's the y-intercept?
For which equation?
For the red one, the milk one.
8.
I get y equals 8. So that's up here. Let's call this 10. Let's call this 5. Let's call this 5. And let's call this 10. And if I cover up the y, what do I get for x?
4.
Perfect. Good job. You're getting good at this. There's my red equation. So,
Okay.
and by the way, it's only in the first quadrant, so I don't even have to draw it beyond that because I can't really have negative amounts of those things, right? So that's really it. I don't even have to, I know that my other constraints, so these are my constraints, but I also know that x has to be greater than or equal to 0 and y has to be greater than or equal to 0, right?
Mhm.
So those are my other constraints. And then the milk one, which was 2x plus y is less than or equal to 8. And the flour one, which is x plus y is less than or equal to 5. Okay, so let's do that flour one now. What's my y-intercept?
Y-intercept would be 5.
And what's my x-intercept?
5.
Do you see how nice it is to have that little trick that I taught you?
I can.
It's called the cover-up method.
Yeah.
Love it. More specifically, it's Mr. Dwyer's cover-up method.
Gotta add that. Yeah.
That's right.
So
it kind of looks to me like they intersect right here. Doesn't it look like that to you? Doesn't it look like they intersect at 3, 3, 2?
Yeah.
Let's check if that's true. 3 and 2. Yep, that equals 5. 3 and 2. Yep. So I don't actually even have to solve the system because I can see that it works. I can see that that point is 3, 2, right? So I'm going to write that in 3, 2. And we know that it's shaded which way?
Below.
It's shaded below. So I don't really even have to mess with, right? That's just going to be where it's shaded. Follow? So this point right here is what? What's that red y-intercept or x-intercept? Remember that was 4, 0?
Yeah.
And what was this blue point up here?
Whoops,
I wrote it's 0, what? 0, 5. And then of course this is 0, 0, which is not going to be the answer because we're trying to maximize the profit. But what do I have to do? Technically, I have to put all these points in here and see which one gives me the biggest profit.
Yeah.
So I'm going to put my x, y's in like this, and I'm going to write 0, 5. I'm going to write 4, 0, and I'm going to write 3, 2, and I'm guessing 3, 2 is going to be the answer, but it's not always the answer. Sometimes it's another one. I can't even write 0, 0, but that's just 0. So what's 0, 0, 5? If I plug in 0 and 5, I get what for the profit?
13.
Nope. If I plug in 0 for x,
10.
good, I get 10. And if I plug in 4 for x and 0 for y, I get what?
12.
12. And if I plug in 3 and 2, 9 plus 4 is
13.
13. Woo woo! You
Nice.
make $1 more. But can I just make one point? You might want to just forget it and not bother buying all the blueberries. If it's easier just to make 4 things of banana.
Yeah.
But you also want variety. So maybe it is better. Maybe it is better to have that. In fact, if this number was less, maybe you can make an argument that, you know what, I know I'm not making as much money, but I want variety because I'll have more people coming here and I'll sell out every time.
There you
'Cause
go.
that's the other question, supply and demand. Which one are you going to
Yeah.
sell out of?
I don't know if my math teacher would like that, but
Oh, your math teacher would love it. That's the new math. That's the new math.
yeah, there you go.
All right. Was that it for you, Sarah?
That is it. Thank
All
you.
right. Now, watch this. Let's see how this works. I'm gonna
Okay.